Welcome back, everybody. This is our first class in JEE mains previous year questions for chapter Oscillation of class 11th. Before this video, in this series, we have made videos for several other chapters of class 11, and all of those videos can be found on our YouTube channel. Again, name of channel is Point Basics, and there is a dedicated playlist for this type of videos. So you can go to our channel and find those videos in the playlist. We have also started a similar series for NEET previous year, so you can also watch those videos, and if you found them useful, you can share them with your friends and like these videos, share as much as possible, and subscribe to our channel. It helps a lot when you share and subscribe. Also, if possible, do make some donations by scanning any of these QR code. It helps us a lot to keep on continuing this series and keep on bringing you quality videos. So with this, let's start today's video with question number 1. So position coordinate of a particle moving in 3D space given by x, y, z. So we have to find out the speed of the particle. So we have position coordinates means we are given displacement. So using displacement we can find velocity for individual directions, like we have x is equal to a cos omega t. Then velocity in x direction will be given by dx by dt, and that will be derivative of this, that will be minus a omega sine omega t. Similarly, from we can find vy will be a omega cos omega t, and vz will be a omega. Now in options we have given magnitude, so we have to find out the net velocity in magnitude. So velocity vector will be here like something like this, minus a omega sine omega t I plus a omega cos omega t j plus a omega. Okay, this is the velocity vector, and magnitude will be a square omega square into sine square omega t plus squaring this a square omega square cos square omega t plus square of this term a square omega square. Now we can take a square omega square common from sine square omega t and cos square omega t. So this will be, we will be left with a square omega square sine square omega t plus cos square omega t plus a square omega square. Now this term will reduce to 1 as per identity. So what we will be left? We will be left with 2a square omega square, and that will be equal to root 2a omega. And here it is, sorry, not root 2a omega, it will be root 2 and a omega outside of root. So option A will fit the answer. Moving to next question. So two simple harmonic motions are at right angles. They are combined to form a Lesch-Jose figure, and xt is given by a sine at plus phi, and yt is given by b sine bt. So we have to identify the correct parameters. So let me slide it slightly. Now we are given that they are at right angle to each other. So when we form Lesch-Jose figure, then journal equation for Lesch-Jose figure is that we are given a basic form that is already here in given, a sine omega t plus delta, and y is given as b sine omega t. Now Lesjaw's equation is x square by a square plus y square by b square minus 2xy by ab into cos of delta is equal to sine square delta. So this is the basic equation for Lesjaw's figure. Now here we have given that they are at right angle to each other, means that delta is 90 degree. So what we do, we put here delta is equal to 90 degree. Now cos 90 is, we know, is 0. So we will be left with x square by a square plus y square by b square equals to sine square delta 90, that will be 1. So we will be left with this type of equation, and here we don't know that a or b are equal or not. So if a and b are equal, then this represent circle, but if a or b are not equal, then it represents ellipse. Okay, so if we see here in options, we have curve is ellipse, delta we know is already mentioned is pi by 2, and a is not equal to b. Okay, and also this to work fully, this equation to work fully, the omega is omega here should be the same, value of omega will be same for both of these, and here for omega in x we have given a, and for omega in y we have given b, so they should be same. So a is equal to b to form a Lesjaw's figure. So a is equal to b, a is not capital A is not capital B, and delta is pi by 2. So this form a elliptical curve. So option C will be the right answer. Now moving to next question. The ratio of maximum acceleration to maximum velocity in SHM is 10. At t is equal to 0, the displacement is 5 meter. What is the maximum acceleration? Initial phase is pi by 4. So if you note carefully, in the second line it is mentioned that at t is equal to 0, the displacement is 5 meter. So what does it means? It means that generally we have two forms of SHM. If we are using here x, okay, so x can be a sine omega t plus phi, where phi is phase, omega is angular velocity, and similarly we can also have x is equal to a cos omega t plus phi. We can use either of these equations. It depends upon the type of question which we have been asked. So here at t is equal to 0, displacement is 5 meter. So at time t0 we have some displacement in the form of t. Suppose we put t0 here and phi is equal to 0. If we initially neglect phi, then this will form x is equal to 0, because sine 0 is 0. So initial displacement will be 0. But in case of cos, when time is 0, we have maximum displacement. So it depends upon the question what we choose, and if we are given initial phase difference, then whatever we choose we will get the same answer. So we will do it via both. We will use this one, and we'll show that if you are given initial phase, then it does not matter whichever equation you choose. But if you don't have initial phase difference, then you have to be careful while deciding that you are going to use sine or cosine. So first we will use solving using sine. So x is equal to a sine omega t, and initial phase is given as pi by 4. So it is pi by 4. So this is our base equation. Now displacement is 5 meter when time is 0. So x is 5 is equal to a sine 0 as time is 0 plus pi by 4. Now sine pi by 4 is 1 by root 2. From this, a5 is equal to a into 1 by root 2. And what we get? We get a is equal to 5 root 2. Now, the ratio of maximum acceleration to maximum velocity. So, maximum acceleration is given by, in the form of amplitude, only we are talking about only amplitude, is omega square a, and velocity maximum we know that is omega a. So if we divide both of these, it is given, if we divide both of these, we will get omega square a by omega a, and it is given equals to 10. So from this we will get omega is equal to 10. And what we have to find? We have to find out maximum acceleration. So again we have to find a max. So a max will be omega square, omega is 10, so omega square is 100 into 5 root 2, that will give us 500 root 2. That is option B. Now let us solve it using a cos omega t plus phi. We will use separate color for that. So here now we will be using x is equal to amplitude cos omega t plus, as phi is already given by pi by 4 and omega we have already solved separately, that is 10. So initial displacement is 5 is equal to a cos, at time is equal to 0, this will reduce to 0 and we will get pi cos pi by 4, and again cos pi by 4 is 1 by root 2. From this again amplitude will be 5 root 2, and again we can easily use same method, again we'll get the same answer. So if you are given with phase difference, it does not matter that much, that whatever equation you choose for calculation. But if you are not given initial phase difference and you are considering initial phase to be 0, then it does matter which type of equation you are going to take. Moving to next question. A particle performs simple harmonic motion with amplitude A. Speed is trebled at the instant when its distance is 2a by 3 from the equilibrium position. The new amplitude is, so we have to find out the new amplitude when it is at a distance 2a by 3 from the mean position. Its velocity is tripled. So first we will find out that what is the velocity, what was its original velocity when it was at a distance of 2a by 3 from the mean position. So we know the formula for velocity is omega a square minus x square, where x is displacement from the mean position. So v at displacement 2a by 3 from mean position will be omega a square minus 2a by 3 whole square, that will be 4a square by 9, and what we will get, omega 5a square by 9 whole under root, so it will be omega a root 5 by 3. Now as per statement we tripled this velocity, so now new velocity at a distance 2a by 3 from mean position becomes 3 times of old velocity, so it comes out to be 3 omega a root 5 by 3, so omega a root 5. Okay, now when we triple the velocity, its time period will not change, because time period does not depend upon uh, its velocity. Inversely, velocity depends upon the time period. So here time period will not change, so omega will not change. So we can also write that v dash will be equal to omega times new amplitude, that is a dash square minus displacement from the mean position square. So new velocity is omega a root 5 equals to omega times new amplitude square minus displacement from mean position is same because we are at 2a by 3 from the mean position. So displacement from the mean position is again same. So this will give us 4a square by 9. So omega get cancelled. Squaring both sides, we will get 5a square is equal to a dash square minus 4a square by 9. This adjusting this and adding, we will get 945 plus 449. So a dash square is equal to 49 by 4 a square, and from this a dash is equal to 7 by 2 of a. So sorry, it is 9, so it will be 7 by 3. So option B will be the right answer. Moving to next question. Two particles perform SHM in a straight line but about a same equilibrium point. The amplitude and time period of both particles are same, equal to a and t respectively. At time t is equal to 0, one particle has displacement a while the other has a displacement minus a by 2, and they are moving towards each other. If they cross each other at time t, then time t is, so we have to find out that time what at which time t they will cross each other. And here the most important thing is this line, that at time is equal to t0, one particle has displacement a while the other has displacement minus a by 2. So here we have to consider their initial positions and then we have to form their respective equations. So let's start with first particle. At time t is equal to 0, first particle has displacement a, and as already discussed in some previous questions, I already mentioned that we can take two type of equation. First is a sine omega t, if we are taking without phase difference, let me clear be here, and or we can take at it as a cos omega t. If we take sine equation, then at time is equal to 0, displacement is 0. If we take cos equation, then time is equal to 0, displacement is maximum. And that is the first case here, that at time is equal to 0, first particle has displacement a. So for first particle, we will be choosing this one. So x1 is given by a cos omega t. Now, once we have chosen some form of equation, then in the whole question, we will stay with that, and if we encounter any other displacement at time is equal to 0, then we have to add some phase to it so that we can satisfy that this additional displacement with using same equation. So for x2, we know that time is equal to 0, it has some displacement, so we will add some phase to it, so it will become a cos omega t plus some phase phi, where phi is the phase difference between both of these. And now we will calculate the phi, because at time is equal to t is equal to 0, x2 is minus a by 2, so minus a by 2 is equal to a cos, this is 0 plus phi. So a get cancelled, and here we have negative half is equal to cos phi. So now we have to find the value of phi for which cos is minus half, and that can be easily find out, because we know if we you know the quadrant rule, that after sine to school to college, in second quadrant cos is negative, so phi is lying in the second quadrant, and in second quadrant it will be negative, and in the value of that will be cos 120 degree gives us minus zero point 0.5 or minus half, and that is equal to cos 2 pi by 3. So second equation will become as x2, the value of phi is 2 pi by 3, a cos omega t plus 2 by 3. Now we have equation of first and equation of second, and both have phase difference of so delta phi, phase difference between both of them is 2 pi by 3. We have angular velocity is equal to omega, and as mentioned they are moving towards each other. So both of are moving towards each other, and if they cross each other in time t, then t is equal to. Now as per mention, to meet each other, they have to meet each other, they have to cover this phase difference. This angle has to be covered because this is the phase difference both of them, between both of them, and to meet each other they have to cover this angle. And now as both of them are moving towards each other, uh, suppose this is the first one that is moving with angular velocity omega, and that is second one that is moving with angular velocity omega. So their relative angular velocity, because they are moving towards each other, will add. So we have final angular velocity as 2 omega, like we have solved relative velocities. And here we have theta is equal to 2 pi by 3, and omega, effective omega, is equal to 2 omega. So time we can calculate easily because we know that omega is given by theta by time. So from this, time will become theta by omega, and from this, theta is 2 pi by 3, and we have twice. So here we will write omega final, twice of omega, and omega is given by 2 pi by t. So 2 pi get cancelled, and from this t will go up, and we will get time is equal to small t is equal to t by 6. And now we can match our answer. It will be equal to option D. So option D is the right answer here. Now let's move to next question. A simple harmonic oscillator of angular frequency 2 radian is acted upon by external force F is equal to sine t Newton. If the oscillator is at rest in equilibrium position at t is equal to 0, its position in later times is proportional to. So we have to find equation for position, and whatever it will be proportional to. So let's start. Here we have given some external force. So what we will do, we will form a equation for net force, and then from that force we will form acceleration, then we integrate to velocity, and then we will integrate to displacement. Okay, so let us consider basic equation that we have a basic equation for harm SHM that is given by amplitude sine omega t. From this we can form easily form velocity is equal to a omega cos omega t, and from this we can form acceleration is equal to minus a omega square sine omega t. So this is the acceleration, and as per, if a particle has mass m, then force will be minus m a omega square sine omega t. So this is the force of SHM, and this is some external force. Then F net will be combination of both of these, so it will be sine t minus m a omega square sine omega t, and from this acceleration will be, we will divide it by mass, so sine t by m minus a omega square sine omega t. Now we know that acceleration is equal to dv by dt. So what we do, we will integrate both of these sides to form velocity. So integral dv will be equal to 1 by m integral sin t dt minus a omega square integral sin omega t dt. Now it will be velocity 1 by m integral of sin t. We have minus cos t, and we are not taking here limits. We are just doing basic integral, and minus a omega square. Again, integral of sin omega t, it will be negative cos omega t by omega. And we are not taking the constant, because we in the question we have to just find out that what will be the displacement proportional to. We have to just find the proportionality. So it will finally become v is equal to minus cos t by m plus a omega. This omega will get cancelled, and minus minus plus cos omega t. Now we can integrate it again, because velocity is equal to dx by dt. So dx integral will be minus 1 by m integral cos t dt plus a omega integral cos omega t dt, and integration of cos is sine. So minus 1 by m sine sine, and here we have x plus a omega. Integral of this will be sine omega t by omega. So this will become minus sine t by m plus omega get cancelled, a sine omega t. Now we know value of omega, that is 2. So this will becomes minus sine t by m plus a sine 2t, and this is equal to x. Now let us copy this, so we can compare it with the answer, and if you have some another form, then we can adjust this accordingly. So copy it, and let us paste it here. We have here all the options, and paste it. Now in our answer, both of them are sine. So sine cos is rejected again, and cosine is again rejected. Now we have sine t minus half sine t plus half sine 2t. So we have one here negative and one here positive. So both can't be positive. So option D is again rejected. And how we can form this answer? We can just take here negative sign common. So this will become sine t minus amplitude times sine 2t. We don't know here amplitude, but we get the basic form that it is proportional to sine t minus amplitude times sine 2t. So this will be the right answer. Option C matches, because just we have to find out the proportionality, that how much it will be proportional to. We just have to find proportionality. So proportionally, our option C matches with our answer. Now let us move to next question. So in this question, we have to form a trajectory for the equation that are given to us. So let us start and forming trajectory. We have two equations. X is equal to a sine omega t and y is equal to a sine 2 omega t. Now we can see that omega is for both of them as different. So we will not use here Lesch equation, because Lesch equations are applicable only when angular velocity or time period is same for both. They just have some phase difference. So we have to form uh, y and x equation by only using these equations. So here we have given sine 2 omega t. We can dissociate it into sine omega t cos omega t. So y will be a sine theta, twice of theta is sine 2 sine theta cos theta. So it will be 2 sine omega t cos omega t. And even this cos omega t can be written as, this will be equals to x, sorry, not this, a into sine omega t will be equal to x, so it will be 2x, and cos omega t can be written as under root of cos square omega t, and we can write this cos square omega t as 1 minus sine square omega t, and from this we can write sine omega t is equal to x by a. So this will reduce to 2x 1 minus x square by a square is equal to y, and squaring both side, y square is equal to 4x square into 1 minus x square by a square. So we have this equation which we got with using both of those equations. Now we have to now do hit and trial method, and we will try to fit that whichever we can say option it fits best. So for that, let's start. Suppose x is equal to 0. We will take case 1, that x is equal to 0. When x is equal to 0, this whole equation reduces to 0, and so y is also 0. So at x is equal to 0, y is 0. Option B, when x is equal to 0, y have some value, so option B is rejected. Similarly, option D, when x is 0, y has maximum value, so this is also rejected. So only option A and option C fits for this case. Now we will try that in option C we have that x is increasing, and with x increasing, y increases to maximum value and then reduces to 0 value. Whereas in case of option A, with increasing x, y does not reduces to 0. Okay, and for that what we can do here, case 2, we can take that x is equal to a. When we take x is equal to a, here x is equal to a, so a square by a square is 1, 1 minus 1 0, so y is again 0. So when x will take some value, then y will reduce to 0, and here in this equation y is only 0 at x0 y0, then and other than this there is no value where y is 0, so option A is also rejected. So only option C fits this, we can say this equation properly. So option C will be the right answer. Now let's move to next question. A body is in simple harmonic motion with time period half second and amplitude 1 centimeter. Find the average velocity in the interval in which it moves from equilibrium position to half of its amplitude. So it is moving from equilibrium position to half of its amplitude. So displacement is equal to what we can say a by 2, and we have to find out time period now, that what time it takes to reach half of its amplitude. For that, we can take help of basic SHM equation that x is equal to a sine omega is 2 pi by t. So 2 pi, time period is 0.5 into small t. So as per already mentioned that displacement from mean position is half. So it will be a by 2 is equal to a sine. This will reduce to 1 by 2 or 4 pi into t. So from this get a get cancelled, and so we have half is equal to sine 4 pi t. Now sine is half at 30 degree, and 30 degrees pi by 6 radian. So pi by 6 is equal to 4 pi t. So pi get cancelled and we get t is equal to 1 by 24th of second. Now we have to find our average velocity as per asking the question. So average velocity will be displacement by time. Displacement is a by 2 and a is 1 by a is 1. So displacement is 1 by 2 and it is in centimeter, and time is 1 by 24. So 1 by 24. It will get cancelled and will go above. So answer will be 12 centimeter per second. And here is option C is the right answer. Moving to next question. Which of the following expression correspond to simple harmonic motion along a straight line where x is the displacement and a, b, c are the positive constant? Now we just have to find out the equation that which correspond to here simple harmonic motion. So for simple harmonic motion, there are two basic conditions. That first equation should be representable in the form of sine or cosine function, and second that the acceleration should be proportional to negative of displacement. And from this, if we multiply it by mass, so force should be proportional to negative of displacement. So from this, if we scan all the options, here we have square terms. Square terms can't be represented in the form of sine, cosine, individual sine, cosine. You can use Taylor expansion to form a series of sines and cosine, but that cannot be represented by individual sine. So these both options will be rejected. Similarly for the bx square and only that option minus bx, where it is something that is proportional to negative of displacement, can be a you can say valid contender for expressing it in the form of SHM. So only option D that fits this criteria. So option D will be the right answer. Moving to next question. Here we have again x is equal to a1 cos omega t and y2 is a2 cos twice of the omega t, and we have to find that which equation fits the equation properly, which of the graph equation fits properly. So what we will do, again we will try to form the equation which we have done earlier already. So here x is equal to a1 cos omega t and y is equal to a2 cos 2 omega t. Now we know that cos 2 omega t is equal to twice cos square omega t minus 1, and here from this first equation x by a1 is equal to cos omega t. So this can be written as a2 twice of x square by a1 square minus 1, and this will be y is equal to a2 2 x square a1 square minus 1. So this is the form of parabolic equation. In general parabolic equation, we have y is proportional to x square, and if y is equal to, some can say 4ax square, it is the equation of parabola whose center where both x and y can be 0, but in this equation both x and y can't be 0. So first of all, this is equation of parabola, so that option D, that is representing a straight line, gets straightforwardly cancelled. Now what we can do again, we can just do hit and try by putting just some point. So let case 1, when x is equal to 0, when x is 0, this will term reduces to 0 and y becomes minus a2. Okay, so here when x is equal to 0, y is negative. This graph, x is equal to 0, y is positive and negative. It has both values. We don't have here both values, so this get cancelled. Here when x is equal to 0, y is positive. So again this graph is rejected. Only option A, when x is equal to 0, y is negative, gets satisfied. Hence option A is the right answer for this question. Now let's move to next question. One more question I think we can solve. The displacement is of a pendulum for 2 pi by 3 correctly represented by. So using this equation with phase of 2 pi by 3, we have to find that which of the graph correctly describe this pendulum equation. So for that, what we do, we will just have to solve this equation for various cases and then we will find the answer. So y is given as a sine omega t plus phase is 2 pi by 3, where a is the amplitude maximum possible. So what we can do here, we can find out that what is the value of y when t is equal to 0. So y t is equal to 0, it will be a sine, this term will be reduced to 0 and will 2 pi by 3. So now sine 2 pi by 3 means sine 120 degree, and sine 120 degree can be written as sine 90 plus 30, that is cos 30, and cos 30 is root 3 by 2. So it will be a into root 3 by 2. And if you know this value, root 3 is 1.73 by 2, that is 0.86, so less than a. So at time t is equal to 0, the value of amplitude is slightly less than a, but not maximum value or not zero value. And here you can see that when time is 0, at this point amplitude is 0, value of y is 0, so option C is rejected. Here in option D, when time is 0, amplitude is maximum, so again this option is also rejected. So we have option A and option B, that can be the both possible answers. Okay, now we will have to examine both option and A and B for the right answer. Now let's move forward. Y is given as a sine omega t plus 2 pi by 3, that is 120 degree, so we can write it like 90 plus 30. And why we are doing this, you will understand slowly, that it will be written as a sine 90 plus omega t plus 30, and we know sine 90 plus theta is cos theta, so this can be written as a cos omega t plus 30. Now as time increases, as time or t increases, omega t will also increase, and in short omega t plus 30 will also increase. and we know that cos is a decreasing function, that cos is a decreasing function, value of cos decreases with time, not increases with time, right? So value of cos decreases with time, not increases with time. And here we are taking time after t is equal to 0, that once time is started at t is equal to 0, the value of cos will decrease. So value of y, that is y is equal to a cos omega t plus 30, this angle is increasing, and when angle increases value of cos decreases, so amplitude will also increase, but after t is equal to 0, that at t is equal to 1, t is equal to 2, t is equal to 3, the value of amplitude will decrease. And here in option b you can see that after t is equal to 0, amplitude is increasing slightly then decreasing, whereas in option A, amplitude is decreasing. So only option A fits our this you can say inquiry or this statement, but option B does not fit it. So option A is the right answer. So with this we will end this video here. Hopefully whatever we have covered in this video is useful and helpful to you in your study and in making your concepts more clear. So again, if you have any doubts or any suggestions, you can put them in comment section. I will try to answer them and all. And if you like this video, then do press the like button, share it as much as possible, and subscribe to our channel. It helps a lot when you share and subscribe. Also, if you can make some donations, then scan this any of these QR codes and do make some donation. It helps a lot to keep on making these videos and keep on continuing this series. And at last, again, thanks for watching. We will meet in next video.